about that one-dimensional distance and points that can be found on a number line. But today, instead of either going the full distance between 2 points or halfway between 2 points to find a midpoint, we will be going a fraction of the way between 2 points. And that fraction can change based on the problem. So if they tell you to only go 2/3 of the distance, or if they say, where would I be located, or at what coordinate would I be if I go 75% of the way, right? So that's what we're going to be working on today. Before we do that, we need to define a couple of terms. First being a line segment. Any guesses what a line segment is?
Like a line with 2 dots at the end.
Very good. Yeah, it's part of a line, so it's got those 2 endpoints. So this would be part of a line containing 2 endpoints. As well as any points that fall in between those 2 endpoints. One-dimensional coordinate system, which this is what we talked about yesterday. We said one dimension means you can only go back and forth in one particular direction, right? So on a number line, we said we can go left and right, but we can't go up and down. So our one-dimensional coordinate system was that number line, which has numbers used as locations of points on a number line. All right, and then lastly, fractional distance. Kind of like what I touched on earlier, this would mean we will only go a fraction of the total distance between 2 points. So this would be a portion of a distance between 2 points. And then similar to yesterday's notes, they then go on to give us this real-world scenario where it says when a plane is flying between major cities, the pilots are required to check in at certain intervals of the trip. This way, air traffic controllers can keep tabs on exactly where all the aircraft are in the skies. If a pilot is required to check in when his or her plane's distance is at a ratio of 3:1 of the total flight distance, what is the total distance flown, and at what will be the coordinate of the plane? See the map below and solve this problem. So they give us this picture representation here, but we don't yet know how we're supposed to find a fraction of the distance or a coordinate that isn't right in the middle. So we're going to first look at what those formulas would be. Before we can solve it, let's talk about the formula. So here's our formula for fractional distance. What is the only thing that you guys noticed to be different about this formula for distance versus the one we had yesterday? There's a K, right? So that K is going to be representing the fraction of the distance that we are supposed to go. Okay, so our K should be either a fraction or a decimal. If they give it to you as a percentage, you can convert it into either one of those. And our x2 and our x1 still mean the same thing as yesterday. Those are representing the 2 points that we go between, right? So our x2 would be where we are ending, while our x1 was our starting. right, so now that we've defined all of those variables in the equation, let's look at a couple of examples. So here on A, it says find 2/3 of the distance between the coordinates 12 and 33. So I just need to pick which variables go where. So what's my K? 2/3, okay? All right, and did they specify which one was x1 and x2? No. So if they don't specify, we always assume that means we move from left to right on the number line. So that would make this my x1 and this my x2. Now I'm just going to go and substitute all of this information into the fractional distance formula. So I'm going to have that fractional distance is equal to k, which for us, you guys said that was 2/3, times the absolute value of x2 minus x1. What's that going to be for us?
33 minus.
Good. Okay, and just like we talked about yesterday, we treat those absolute value bars like we would a parentheses. We need to simplify what's inside before you worry about what's outside. So I would go ahead and subtract here. What is 33 minus 12? 21. Okay, so I would have 2/3 times the absolute value of 21. The absolute value of 21 is just 21. So I have 2/3 21. When two terms are beside each other like that, what operation does that mean? Multiplication. So, yes. Oh, okay. So 2/3 times 21 would give us 14. Nice. So if we only go 2/3 of the way from 12 to 33, we would move 14 units on our number line. All right. On B, it says to find the distance from 15 to 35. So this time they were specific about where I'm starting and where I'm going. So I went from 15, my starting point, to 35, my ending point. Okay. And it has a ratio of 3:1. So they didn't come straight out with our K this time like they did in the previous example. So we're going to have to create a fraction or a decimal based off of this ratio. We should know a ratio is just a type of fraction, right? You're comparing two terms. All right, so if I have a ratio of 3:1, that means 3 parts to 1 part. So 3, yes, is how we would start that, yes. So we have 3:1, so 3:1. We are starting out with a 3 in our numerator. If there are 3 parts to 1 part, how many parts are there total? 4. So 3:1 has 4 parts, or 4 segments. All right. So it would be 3 out of our total 4 parts. So 3:1 is 3 out of our total 4 parts. Or you could also see this written as a percentage or decimal. Right. So 0.75, which they could have also said as 75%, right? Those all mean the same thing. Okay. So now we have a value for K. They gave us x1 and x2. Now we just need to substitute that information into our fractional distance formula. So I'll have K, which would be either 3/4 or 0.75, whichever way you prefer to write that, times the absolute value of x2 minus x1, which for us would be, there we go. Okay, and what is 35 minus 15? 20. And the absolute value of 20 would just be 20. So I would just need to multiply 3/4 times 20, which would give us 15. So if we only go 75% of the way, or 3/4 of the way between those 2 points, we would travel a distance of 15 units. All right. Okay, so we got fractional distance down. Let's flip it over on the back and talk about coordinate. Okay, so yesterday we said the difference between what we were finding with distance and what we found with midpoint is that distance was how far you went, midpoint was a specific location, right? Same is true here. Fractional distance is still how far we've traveled, while a coordinate is going to be a specific location. So if I tell you you started at 1 and you're going to 20, and I ask you to only go 3/4 of the way there, this formula tells you what number you would land on if you went 3/4 of the way there. All right? So the formula, if you notice, is the same formula as it was for fractional distance with this little extra part right here in front. Either x1 plus that formula or x1 minus that formula. And that will be determined by whether you're traveling from left to right or right to left. Yes. Oh, like moving left and right, like when it's in parentheses. Yes, but whenever it's in parentheses, remember it's opposite of what it says. But yeah, right idea. Yes, I see where you're going with that. So if we are going to add, that means we have moved left to right on the number line. If we are going to subtract, that means we're going backwards on the number line. Like the example from the notes from yesterday where we went from B back towards A. Then we would subtract. All right? Okay, so we've got our formula. Let's look at some examples. Example A says to find the coordinate of the point that is 60% of the distance from 105 to 136. So here's my 105. Here's my 136. Am I moving left to right or right to left? Left to right, because it said I start here and I go here. So that would mean I'm using that first formula, right? Okay. So this would be my x1 and my x2, and what's my k? 0.6. Good. K will be 0.6. All right, now we just plug all that information in. We said we're using top formula, so we've got our x1, which is 105, plus k, which you guys said was right, times the absolute value of x2 minus x1. Okay. Again, remember we treat those absolute value bar like we would a parenthesis, so I simplify inside first. So what is 136 minus 105? 31. So I'll have 105 plus 0.6 times the absolute value of 31. Well, the absolute value of 31 is just 31. All right, so now I've got addition and multiplication left. Order of operations says to do what first? So what is 0.6 times 31? 18. Good. And now I can add. So what would 105 plus 18.6 give us? 123.6. So if you go 60% of the way from 105 to 136, you would land somewhere in here at the point 123.6 on the number line. All right, let's look at another example. Find the coordinates of the point that divides the line segment below into a ratio of 2 to 3. Did it say which one is x1 or x2?
No.
No. So we have to assume that we're moving left to right. So that would make 13 my x1, sorry, negative 13 my x1, and 17 my x2. All right, so this time they gave me that ratio again, so I need to turn that into a fraction. What would my fraction be? 2 over 5, very good. So we picked this number, since it was listed first, out of the total 5 parts. So here's my k. That also can be written as a decimal. What is 2 fifths as a decimal? 0.4. All right, so we would have, since we're moving again from left to right, our x1 plus k times the absolute value of All right, and what is 17 minus negative 13? 30. And the absolute value of 30 is just 30. All right, and then you guys said order of operations would tell us to multiply first. 12, so we have negative 13 plus 12, which would give us negative 1. There we go. So if we were to go 0.4 of the distance between these 2 points, we would land on the point negative 1. All right, so now we know how to use the formulas. Revisiting that information from the front page, we're talking about the airplane. They want to know how far will you go if you travel that specific fractional distance, and they want to know where you will be if you go that specific fractional distance. So we know this is our x1 and x2. Based on the information from the front page, what would my k value be? 3/4. Or I could also write that as 0.75. Good. All right. So we're going to start with our fractional distance. So that's our k. So either 3/4 or 0.75, whichever you prefer to use, times the absolute value of x2 minus x1. And we simplify inside the absolute value first. So what do I get when I subtract those? Yes, 608, good. And we know the absolute value of 608 would just be 608. All right, so what do I get when I multiply those? Good. So the fractional distance traveled would be 456 miles. Okay? All right, now I also am supposed to be finding the coordinate location. Okay, did we move left to right or right to left? Left to right. So we're going to be using the first formula, which is x1. So for us, that would be the 138 plus, and then we copy down the fractional distance, right? 0.75 times the absolute value of 746 minus 138. Well, we already did this part right here, right? And we got, so really I just have 138 plus 456. Nice. So I would land on the number line at the point 594. All right?